Yeah, good morning all. Now I am going to explain about root locus diagram. Okay, see here, the purpose of this root locus diagram is to analyze the stability analysis of a closed loop control system from the open loop system. That means in this problem he is given g of s into h of s, that is a open loop system, right? By knowing that open loop system we can determine the stability of closed loop control system. Okay, to construct this root locus diagram, these are the very important steps, 10 steps. Okay, first point is every branch of the root locus diagram, RL is nothing but root locus diagram, starts at a pole k is equals to 0 and terminates at a 0. Remember this point. Okay, I will explain while constructing the root locus diagram. Okay, that means every branch of the root locus diagram starts at a pole k is equals to 0 and terminates at a 0, k is equals to infinite of the open loop transfer function of g of s into h of s. Okay, that is the first point. Next, second point, RLD is symmetrical with respect to x axis or real axis. Okay, RLD is symmetrical with respect to real axis. Next, number of branches of RLD, where n is number of root locus branches of RLD is equals to p. If number of poles are greater than or equals to z, then the number of branches will be p, and number of branches is equals to z if z is greater than or equals to p. Okay, this value, this will determines the order of the system. Next, centroid. Okay, centroid is nothing but the sum of real part of poles minus sum of real part of zeros divided by p minus z. Okay, this centroid is always present on the root locus diagram only, centroid sigma. Okay, that means based upon the values we are getting from this, we can identify that centroid. Okay, this centroid value is always real. Next, angle of asymptotes, that is represented by theta L or theta Q. Here I am representing with theta Q, right? Then theta Q. Okay, thus theta suffix Q is equals to 2q plus 1 into pi by p minus z. Okay, where q is equals to 0, 1, 2, so on, magnitude of p minus z minus 1. Okay, next point, on the real axis to the right side of any section, sum of total number of open loop poles and zeros are odd, then only RLD exists. Okay, now here I am explaining about this first point. Every branch of the RLD starts at a pole and terminates at a 0, k is equals to infinite, right, of the open loop g of s. Now see here, let us consider a example. In this example, what is given? S plus 1 by s into s plus 2 into s plus 3 into s plus 4. Okay, here s is equals to 0 is one pole, s is equals to minus 2 is one pole, s is equals to minus 3 is another pole, s is equals to minus 4. That means total number of poles are 4, s is equals to minus 1 is 1, 0. Now see here, this is the representation of pole 0 plot, right? Okay, s is equals to 0, one pole is present, s is equals to minus 1, 1, 0 is present. Next, s is equals to minus 2, one pole is present, s is equals to minus 3, another pole is present, s is equals to minus 4, another pole is present. Now see here, pole to 0, right? That means k is equals to 0, pole is present, k is equals to minus 1, this is 0, pole to 0. That means 0 indicated by k is equals to infinity. Here also pole to 0, here k is equals to minus 2, pole to 0. First we will see how to determine the sixth point. On the real axis to the right side of any section, sum of total number of open loop poles and zeros are odd, then only RLD is exist. Now see here, s is equals to 0, one pole is present, right? Okay, I can close the remaining all those terms, right? Then here sum of poles and zeros. Okay, from my right hand side, sum of poles and zeros will be odd, right? Only one pole is present, hence RLD is exist from 0 to minus 1. Next, I can close the remaining 3 poles, then the sum of poles and zeros will be 2, right? That is even, right? Okay, one pole and one zero, sum of these two will be 2, that is even number, then there is no RLD exist from this pole, this 0 to pole. Next, after that close the remaining 2, then the sum of poles and zeros will be 3, right? Then RLD is exist between -2 to -3. Okay, next, now see here, next I am closing this pole, then sum of poles and zeros will be 4, then no RLD is exist, right? After that I can close this one, then the sum of poles and zeros will be 5, 1 2 3 4 5, right? Then RLD will be exist from this point to infinite. Now see here, from this first point, every branch of the RLD starts at a pole k is equals to 0 and terminates at 0, k is equals to infinity, right? Now see here RLD exists, right? That means this is k is equals to 0, k is equals to infinite. Okay, pole to 0. When RLD exists in that branch only, this is RLD exists. This is the direction of RLD. Okay, pole to 0 direction. Next, in between 2 and 3 also RLD is exist, right? But the RLD direction is from, see here, first point, RLD direction is from pole to 0, right? Now here we need to calculate angle of asymptotes, that is theta L. Okay, this theta value, if we simplify this theta value, we are getting 60 degrees, 180 degrees and 60, 180 and approximately 5 into 60, 300, right? Now you will get an angle like this, 60, this is 300. Okay, that means this is k is equals to 0, this is also k is equals to 0, right? Now this is the direction of RL, k equals to infinite. Here it will end another pole, right? K is equal to 0. Here k is equals to at infinity, another 0 is present. That is the assumption. Similar way, here also RLD is exist, right? Here k equals to 0 at infinite, at k equals to infinite, 1 0 is present. That is the assumption. In this way, we can construct the RLD. Okay, if you solve another problem, then you have a clear idea. Okay, in this way we can represent, that means every branch of RLD will start from pole to 0, right? Pole to 0, right? Pole to 0, pole to 0. Next, pole to 0 direction. Next, calculation of k value. Okay, maximum, we may get question from this topic. Why? Because it is simpler. Maximum calculation of k value. K is equals to, at S is equals to S1, product of distance of vectors from various poles of g of s into h of s to S is equals to S1 divided by, same again, product of distance vectors from various zeros of g of s into h of s to S is equals to S1. Okay, or k of S is equals to S1 by 1 by magnitude of G1 of S into H1 of S. That means in this magnitude we need to substitute S is equals to S1. This is also, if you solve one problem, you have a clear idea. After that, break away or break in point. Okay, to calculate break away or break in point, we need to differentiate k value dk by ds and is equals to 0. Then we will get break away or break in point. After that, d square k by ds square value is positive, that is break in point is minimum. Okay, d square k by ds square value is negative, that means again we need to differentiate this value. If that value is negative, that is break away point, that value is maximum. Okay, that is about break away or break in point. Next, angle of departure. Angle of departure is calculated at a pole. Okay, that formula will be pi d is equals to 180 minus pi. Okay, angle of arrival at a 0, this is not pole, it is a 0. Angle of arrival at a 0, that means if number of in the given g of s into h of s, if numerator power is more, then we need to calculate angle of arrival. Okay, here pi value is calculated by using this formula, sum of poles minus sum of zeros of g of s into h of s at s is equals to s1. Next, last point is point of intersection of the RLD with respect to imaginary axis. Okay, this point of intersection will be calculated by using RH criteria. Already we know that RH criteria, if suppose g of s into h of s is given, right, you need to construct RH criteria means first you have to write characteristic equation, right? That is 1 plus g of s into h of s is equals to 0. From that equation we need to calculate k value. Okay, in that k value, first if we equal s power 1 value is equals to 0, okay, then we will get k value. After that, in that auxiliary equation, that means s power 2 value, in that auxiliary equation if we substitute that k value, we will get s square term. Okay, in this way we can calculate k value. Okay, now we will see all these 10 points in one problem. Okay, what is given? G of s into h of s is equals to k by s into s plus 2 into s square plus 2s plus 10, right? Determine the angle of asymptotes. Okay, angle of asymptotes is nothing but theta q. We need to determine theta q. But in this problem, I can explain each and every point. First, what is given? Number of poles are how many poles? 4. Number of zeros are 0, right? S is equals to 0, 1 pole. S is equals to minus 2, another pole. Next, s is equals to minus 2 plus or minus under root b square 4 square, sorry 2 square 4 minus 4 ac, that is minus 40, that is under root 36. J36 means j6, right? You will get by 2 into 1 2, you will get another root will be minus 1 plus or minus j3. Okay, these are the roots. Okay, number of poles will be 4, number of zeros are 3. Then what is the first point? RL, the number of RLD branches is equals to number of poles here. Number of poles will be greater, right? The number of RLD branches is equals to 4. Okay, from this third step, third point. Next, here I can calculate centroid sigma. Okay, centroid sigma is equals to sum of real part of poles, minus sum of real part of zeros divided by p minus z, right? Sum of real part of poles, see here, real part 0, sum, real part, another real part minus 2. Next, minus 1 minus 1, 2 times is repeated, right? Minus 1 minus 1, no zeros are present, 0. P minus z value will be 4, that is centroid value will be minus 4 by 4. You will get centroid as minus 1. Okay, if I draw the pole 0 plot, s is equals to 0 is one pole, s is equals to minus 2 is another pole. Next, s is equals to minus 1 plus or minus j3, right? Here it is plus j3, here minus j3. Assume here, that means here this is, assume here it is minus 1, right? This is minus 1 plus j3 is one pole, minus 1 minus j3 is another pole. Now see here, if I close starting poles, only one pole is present, right? This is the representation of minus 1 plus j3, minus 1 minus j3, right? Then the sum of poles and zeros will be only 1, that is odd number, right? That means here RLD is exist, right? Next, now see here, if I close this pole, again sum of poles and zeros will be 3. Again here also RLD is exist. Okay, next, if I close this one, sum of poles and zeros will be even, right? Then no RLD is exist. Okay, in this way we can represent the RLD. Here RLD will be exist, right? Centroid is also exist at this point. Next, theta q is equals to 2q plus 1 into 180 degrees by p minus z plus or minus, right? Now see here q value is nothing but p minus z minus 1, p minus z value 4, that means q value will be varies from 0, 1, 2, 3, 0, 1, 2, 3. If q value is equals to 0, q value is equals to 0, 180 by 4, that is 45, plus or minus 45, comma, q value is 1, 3 into 45, that is 135, Next q value is 2. 5 into 45, right, that is 225 degrees. Next q value is 315 degrees, right. Now see here, from this centroid is equals to -1, right. Then if I draw the plot, 45, 135, 225, 315, okay, from the theta value, okay, theta value is completed, right. Centroid is completed, angle of asymptotes completed, right. In this problem he is asking angle of asymptotes, that values are 45 degrees, 135 degrees, 225 degrees, 315 degrees is the answer. Okay, in this problem only we can solve all those problems. That means here centroid is completed, angle of asymptotes is completed, right. Where RLD is exists also completed, right. Next here, first of all I need to calculate break away point or break in point. Okay, what is given here? G of s into h of s is given, right. Okay, to calculate break away point we need to consider the equation 1 plus g of s into h of s is equals to 0. That is 1 plus k by s into s plus 2 into s square plus 2s plus 10 is equals to 0. If I simplify this equation, s into s plus 2 into s square plus 2s plus 10 plus k is equals to 0, right. Then I am writing direct equation. If I simplify this equation, k value will be s power 4 plus 4s cube plus 14s square plus 28s plus 20 is equals 20. Okay, then if I differentiate this k value and differentiate with respect to s and equals to 0, okay, that is dk by ds is equals to 0. Okay, I will get s value, that is point of intersection. Okay, point of intersection, that s value will be -1 comma -1 plus or minus j2. Okay, in this way we can determine the s value. Okay, after that if I want to calculate break away point and break in point, d square k by ds square is equals to 0, right. In this case we need to substitute s values. One time we need to substitute s is equals to -1, one time, okay, first we need to substitute s is equals to -1 in this d square k by ds square. After that -1 plus j2, after that -1 minus j2. Okay, now see here, if this, after getting this d square by k by ds square, if I substitute all those values, if that d square k by ds square value is positive, then that is a break in point. If that value is negative, that is break away point. Okay, you can simplify this equation. I am not explaining about this procedure. Why? Because this is complicated. Okay, this type of problems may not get, but sometimes we directly may ask the roots. That is the possibility thing. Okay, in this way we can calculate break away point and break in point. After that, what is the ninth one? Angle of departure or angle of arrival, right. Okay, suppose here it is having poles, right, then we need to calculate angle of departure, that is 180 plus 5. Okay, to calculate this pi value, okay, to calculate this pi value, see here, what is the g of s into h of s value? K by, I am writing this value as it is, k by, in place of s I can substitute j omega, sorry, better, phi is equals to some constant, right, k by s into s plus 2 into, see here, already this s square plus 2s plus 10 roots are calculated, right, -1 plus or minus j root 3, right. I can express this value in terms of roots, that is s -1 plus j into 3. Next s -1 minus j into 3. Okay, phi is equals to k by s into s plus 2 into s minus 1 plus j3, s minus 1 minus j3. Okay, to calculate this value in this angle phi, okay, in place of roots you can substitute any one complex root. You need to substitute only complex root. That means here I can consider s value as s is equals to See here, from this equation I am considering minus 1 plus j3. Minus 1 plus j3 I am considering here. Then phi value is equals to, here only constant, right? Constant angle will be 0 degrees, right? Next, here s value I am substituting minus 1 plus j3. Okay. Next, s plus 2. In that s plus 2 I can substitute minus 1 plus j3 plus 2. Okay. Next, here in place of s I can substitute minus 1 plus j3 minus 1 plus j3. Next equation, minus 1 plus j3 minus 1 minus j3. Where s is present, in place of s I can substitute minus 1 plus j3. Otherwise you can substitute minus 1 minus j3 also. Anyway you will get same answer only, right? Now see here, phi is equals to, in numerator is, there is no s term, there is no imaginary part, right? Then angle will be 0 degrees. Here minus 1 plus j3. Next, minus 1 plus 2, that is 1 plus j3 minus 2 plus j3 plus j3 and minus j3 will be cancelled. You will get minus 2, right? Now if we consider angle, phi is equals to 0 degrees by r plus jx form, right? This is tan inverse y by x, that is 3 by minus 3 by 1. Next, 1 plus j3, again tan inverse y by x, that is 3 by 1. Next, tan inverse minus 3 by 2 into minus 2. Okay, if it comes to numerator, you will get the angle. In this way we need to calculate first phi value. Okay, after calculating this phi value, angle of departure pi d is equals to 180 plus, suppose if I simplify this equation, I will get phi value. When it comes to numerator, I will get minus tan inverse minus 3 by 1, right? Again tan inverse 3, tan inverse minus 3 by 2. Assume, just approximate value I am assuming 140 degrees. Then I will get pi d value as plus 40 degrees is the answer. In this way we can calculate angle of departure or angle of arrival. Okay, thank you all.